Page 2 of exam 3 review. We've got a polynomial here. We're going to find the degree, leading term, leading coefficient, and behavior, y-intercept, and the zeros with the multiplicities of each. Luckily, it's already factored for us. If there was a coefficient of these x's, that is part of our leading term. So that would need to be calculated with this. So if there was a 4 here, you would take 4x and cube it. But there's not, there's just x cubed. X squared. So that means our leading term is x to the 5th. X to the 5th. Our degree is 5. Our leading coefficient is 1, because there's a coefficient of 1. If there's no coefficient, it's not 0, because then you wouldn't have x to the 5th. It's just 1. Our end behavior with a positive leading coefficient and an odd exponent, it's going to be something where it's going up this way and down this way. So that's how I use that to find my end behavior. Or you can use that chart that we used in class. So as x approaches negative infinity, it's heading south. F of x is approaching negative infinity. As x approaches positive infinity, f of x is approaching positive infinity as well. Next thing we want is the y-intercept. Y-intercept is we just plug in zeros for our x's. So k of 0, 0 minus 3 cubed times 0 minus 2 squared. Negative 3 cubed is going to be negative 27. Negative 2 squared is going to be positive 4. So negative 108. So my y-intercept is 0, negative 108. That means it's going to come way down here to negative 108. All right, I'm just trying to do a little sketch to see what it's going to look like. And then, what's next? Zeros. Find the zeros and multiplicities of each. Oh, fantastic. They give them to us. So take x minus 3 and set that equal to 0. Take x minus 2, set that equal to 0. Solve for x, add 3 to both sides. X is equal to 3. And add 2 to both sides. X is equal to 2. The multiplicities has to do with what the exponents are. This one has a multiplicity of 3. This one has a multiplicity of 2. Okay. Next, given the graph. So given this graph, we need to find the zeros. We've got that right here. So x is equal to negative 4. I'm going to write it over here. X is equal to negative 4. X is equal to negative 3, negative 1. And 3 and 4. All right, the multiplicities of each, they all look like they are just single lines. So multiplicities will be 1 for each. Find the y-intercept, that is 0, negative 1. And in behavior, it's going up and then down. So let's go ahead and do that. Let's go ahead and finish our creating our, oh, they're not even asking for it yet. We'll do that. Okay. In behavior is as x approaches negative infinity, f of x is heading north to positive infinity. And as x approaches positive infinity, f of x is heading south to negative infinity. All right. And then find the least possible degree. Well, I always base that on my max terms and the fact that it has to be an odd exponent for our degree because they're going in different directions. So our max terms are 1, 2, 3, 4 max terms. We got here 4 max terms are degree minus 1. We have 4 max terms. N minus 1, add 1 to both sides. So we have at least a degree of 5. Least possible degree of 5. Yeah. All right. The next part, let's write the equation for this polynomial. So I'm going to call it f of x. Y'all are cool with that. A, do not forget your A. Set each of these equal to 0. So x equals negative 4. When you set it equal to 0 is x plus 4. Same thing with the x equals negative 3. It would be x plus 3. X equals negative 1, so it's x plus 1. X equals -3, so X minus 3, and X equals 4, so X minus 4. And they all have an exponent of 1 because we decided their multiplicities were 1. All right, let's find our A using our y-intercept. Let f of x equal -1. And all of your x's need to be zeros. So I'm just going to remove those and go ahead and just write 4, 3, 1, -3, and -4. Multiply all this out. 12 times -12. Oh, no, that's all positive. So 144. 12 times 12 is 144. So -1 equals 144a. Divide both sides by 144. And a equals -1 over 144. So now we can write our equation. F of x is -1 over 144. I am not asking you to expand into general form. Please just write this in what we have here. X plus, I'm going to give us more room. F of x, -1 over 144. X plus 4, X plus 3, X plus 1, X minus 3, and X minus 4. There is your, and do we have a degree of 5? Yes, we do. At least 5. So you need to make sure you're at least representing 5 for your exponent. All right. Next one we have is find the zeros of the polynomial function. So we've got f of x, and this is number 7, is equal to 2x cubed minus x squared minus 8x plus 4. That means we just let our y equal 0. Since it's here's 4 terms, I look to see what the first two have in common. They have x squared, so I'm pulling that out. I'm factoring that out, and I get 2x minus 1. Can I make this one look like this? Of course I can. I just factor out a -4, and I get 2x minus 1. You can check that by distributing that -4 back in to see if we get the same thing. Now, I look at these two terms. What do they have in common? They have 2x minus 1. Hold on, I'll get there. So I factored out 2x minus 1 from this one. I'm left with x squared minus 4 from the second one. That's what's left when I factor out the 2x minus 1. Now I can either keep factoring because this is the difference of two squares, or I can use this square root property for it to solve. Your call. If you see that it's the difference of two squares, then you're going to see x and x, 2 and 2, positive and negative. If you don't, you can use your square root property. So 2x minus 1 equal to 0, x plus 2 equal to 0, x minus 2 equal to 0. Add 1 to both sides. 2x equal 1, divide both sides by 2, x is equal to 1/2. Subtract 2 from both sides, x is equal to -2. And add 2 to both sides, x is equal to 2. We have 1, 2, 3 with a degree of 3. We've represented all of our zeros. The next one is find the zeros of the polynomial function. This is 8. F of x is x to the 6th minus 2x to the 4th minus 3x squared. What do they all have in common? X squared. I'm left with x to the 4th minus 2x squared minus 3. I can keep factoring this. Do not get rid of that x squared. X squared, 3, 1, negative, positive. Go through and check your OI, make sure it works. -3x squared plus x squared is -2x squared, so it works. Take each of these and set them equal to 0. Do not break this into two parentheses. There's no such thing as the sum of two squares. If I did that in class, it was a joke. And I told you it was a joke. Hopefully you heard that. So let's just solve. So x is equal to 0. This has a multiplicity of 2, so it's a doubling of the 0. Add 3 to both sides. X squared is equal to 3. Take the square root of both sides, plus or minus for your constant side. X is plus or minus the square root of 3. Subtract 1 from both sides. X squared is equal to -1. Take the square root, plus or minus on the constant. X is equal to plus or minus I, because remember the square root of -1 is I. All right, there are our 1, 2, 3, 4, and this is a doubling, so 6. Give us gives us the degree that we have here. The next one is, given the information about a polynomial graph, write the equation. We've got a degree of 5, doubling of x at x equal 1, triple at x equals 3, and passes through the point 0.25. I'm going to do this here. So set these each equal to 0. So this is going to be x minus 1, and it's doubled, so squared. And we have x, this is going to be x minus 3, and it's tripled. There we go. And that gives us a degree of 5 when these are added. And it passes through the point 215. So I'm going to write my equation real quick, and we're going to look for our a. Using this point, 15 for my f of x, looking for a, and x needs to be 2. 15 is equal to a. 2 minus 1 is 1. Okay, so 1 squared is 1. That's not going to make a difference. 2 minus 3 is negative 1. Negative 1 cubed is negative 1. So this is a negative. Negative 1 times a is negative 1. Divide both sides by negative, and we get a is equal to negative 15. So my polynomial function is f of x equals negative 15 x, and I don't ask for the general form, just this form is fine. X minus 1 squared, x minus 3 cubed. See you in the next video.